that generic lens needs to be built, and it does. Okay, here we go. So we've already covered a few different ways to define or derive optics for your types, but many of them still leave something to be desired. Template Haskell requires adding splices to your code, which can make it tricky to organize your structures so that their data dependencies work out. Defining them by hand is a tedious task, and that can usually be automated. So what's left? I know, like, I actually support Songor, but I don't actually know how to pronounce his name correctly. So I hope that that's pretty close. I don't know that I've ever heard his name pronounced. So I think it's Songor. Was unsatisfied with these solutions and threw a new contender into the ring, Generic Lens. Generic Lens relies on GHC's generic type class to introspect structures and derive optics on the fly for any given situation. I know he's working on the total program optimizer. Total, is that what it's called? Total something like that. Um, and I think I'm supporting that. So anyway, Generic Lens relies on GHC generic type class to introspect structures and derive optics on the fly. There are a few benefits. Optics are derived as you need them. You don't pay compile time costs for any optics you don't use. You can derive optics for structures from external code bases as long as they have an instance for generic. You can write advanced optics which interact with the shape of your data. I don't exactly know what that final one means yet, but we'll figure it out here in a second. For examples in this section, you'll need to add generic lens as a dependency to your package YAML, and and we'll generally need derived generic data kinds and type applications, which you'll import. Oh, and you'll need to import. Yep, this is totally fine. I'm concerned about that. Okay. Oh, first code snippet. Import. Well, we don't need to do this. We'll do this in a second. We'll copy this and tab that out, which should get us pretty much the rest of the way, I think. Me. Hello, John. I don't exactly know what this is for yet. Like, why do we need John? But we'll probably be using something about John. Okay, anyway, we'll be using type hints to tell combinators from generic lens which fields we want to focus. So we need to make sure we have a few extensions enabled. Type applications. Honestly, I think type applications is one of my favorite GHC extensions. I just kind of like it. It's a cool extension. Allows us to explicitly specify the type parameters of combinators using @ and data kinds allows us to use string syntax to create type level symbols and numbers. So this is a type level symbol enabled by data kinds. Cool. So we can just have like an A, and we can say John view field name. And this is going to complain. We want to add type applications. We want to add data kinds. And this one does not work. Oh, we need field. So import data generics product field. Okay. So right, this is a record that's a product. And so that's just, I guess that's how you do fields for products. Or, well, record fields or something. Here we go. Hey, Swarm, how's it going? I saw I was hosting you, I think yesterday you were working on something, but I obviously had started my stream. So what were you working on yesterday out of curiosity? More mobby stuff? I know I think I've seen that like one time, but I don't remember. Okay, so this might seem a bit like magic at first. We're passing the field name to the field combinator via the type system. So I will say that this isn't actually that weird from my standpoint, only because I've finished thinking with types. So if you're interested in sort of how this kind of stuff works, that's probably a good book to get you started. I think I have a list. I think I have that here. So if you're curious about that. Hey Lumi. Uh can't stay long, but I saw you were saw you were on and at least want to say hello. Well, thank you. Hello. Since Christmas night, I've been working through the Advent code, making good progress. Nice. How far are you through? I saw like a bunch of people like finishing up, so that's got cool. Got stuck on day 13. Finally figured it out. Sweet. Lumi, yeah. I streamed like pretty much every day this week, I think, except Monday. Today's Thursday, right? So I'll probably stream tomorrow as well. Maybe. We'll see. I mean, it just depends on how I'm feeling. I've been feeling pretty good, so I might stream tomorrow again. But we're gonna be working on a more practical project, probably doing some like yak shaving type stuff to get set up for that. We'll see. Okay, so field accepts a type level symbol representing the field name and uses it to introspect the record's generic structure and build the appropriate lens for that field. It does all of this at compile time, so believe it or not, it's completely type safe and it's generally just as efficient as a handwritten lens. Cool. Look what happens if we try to access a field that doesn't exist. Okay, well, let's just see what the error. Well, I mean, I can see the error here. Yeah, I wish I don't fully understand the advent of code thing. I think I tried to do it like a not last year. It would have been the year before that, I suppose. And I just didn't get into it. But I think I just don't like these. I don't know. I don't like those kinds of problems personally. It's just my uh I don't know. I just don't like them. I don't know what else to say. It's probably just because I'm bad at it. Anyway, because it builds the lens at compile time, I just noticed a bunch more people. So hello everyone. Hopefully you learned something. I don't know that this chapter is very long, so we'll probably switch topics in I don't know an hour or so. And if anyone has any suggestions for something they'd be interested in seeing, let me know. But my first idea is let's see if we can get Liquid Haskell working with the LSP, because that's kind of something I've been trying to do, or I wanted to do previously. Anyway, because it builds the lens at compile time, it can check for the field you want to and throw a nice error if it's missing. Yeah, so this is also something you can learn about in thinking with types. Like this is kind of a nice error. I presume that the default error is a lot worse than this. Okay, if it's like really hard, it's more interesting. I suppose that's true, but also more difficult. Anyway, there's deep magic going on behind most of generic lens combinators. Raiders, active fireball. Hey, three Raiders. You've switched topics pretty heavily. What were you working on, Darren? I know you're into the JRPGs, but I don't know which one you're working on these now. Mystical Ninja on the N64. Very cool. I know you like those games. Well, anyway, we're learning Haskell now, so feel free to ask weird questions because we're doing some kind of weird stuff. Apparently, Chris is in the building. Hey, Chris. Also, hi, Daniel. And hi to myself. JRPG to Haskell. That's what we like. Some of the challenges, we're talking about Advent of Code as well. So, some of the challenges are really just reading the input types. Then there are discover the algorithm. I just want to practice Haskell, so this give me a good set of problems. Sure, that's great. Um, oh yeah. Just no need to be active in chat. You can obviously just lurk. What are you writing? Blog post? Um, Anything interesting that you want to share with the group, or maybe not? You don't have to, obviously. Okay. So let's check the type of field in the REPL, and here's what we'll see. Genetic. Ooh, nice. Very cool. Actually, I think I remember you saying something like that on Twitter. So I guess that makes sense. It's very. So one thing I just noticed is I don't think there's nothing in here that's problematic. So this is new. It has the colors matched in Chatterino. I didn't see this yesterday. This is pretty sweet. Um, I've been using Chatterino because the Twitch chat is very weird when you're behind a VPN. Okay. Product fields has field. So this is the type level symbol. Nothing new. Yeah. Well, if they were here for the index optics chapter. Um, okay, so yeah, this is the type level symbol, and then it just looks like the normal lens definition otherwise. Um, we can see it depends on has field type class and seems to be able to build any sort of lens you might want. Yeah. We can use type applications to tell field which field on which record we want to access. So here's the field name and the type or the structure that we would like to match on is person. And I guess it's smart enough to realize that we want person to person, which is interesting. And also smart enough to realize that it's string to string in this particular case, I guess, because these. Oh, wait. Oh, because we use the field name. Right. There we go. Pretty cool. Okay, by filling in the field and record, it has managed to resolve the type class using person's generic instance and filled in the lens types for us. See how it automatically knows that the name field of a person is a string. Pretty cool stuff. I agree. In practice, we usually only need to pass the field name since the record type can typically be inferred from the usage context. Yeah, I mean, like if you're using the field on a particular structure, no, we don't want to become famous. We will ban you forever. Goodbye. Um, script sh. Hello. Hey, how's it going? I'm pretty sure I recognize that name, so happy to see you around. How are things? Are you doing any Advent of Code out of curiosity? Or Haskell? I can't remember. Not particularly interested in the physics, optics, so I've taken all the standard physics classes. I kind of miss physics, actually. Like, in I was originally an engineering major in college, and then I changed to chemistry. Um, liked it better. Indifferent Ghost. Cool name, first of all. Hello. I don't recognize your name, so you are new, I think. Feel free to tell me about what you like to do. Like Haskell, if you're interested in Haskell, maybe not. Right now, we're kind of having a few random conversations about physics. Oh, there's something here about comonads as well. Considering the comonads by example, ooh, yeah, that would be sick. I would be super into the comonads by example because I haven't really dug into those at all, so we'll have to see. Okay, script. Recently, I've been trying to relearn Haskell. Had it 2 years ago in college. Um, cool. How's it going? What are you using to learn? Anything specific? Yes, I am a scientist by training, I suppose. Not a scientist anymore, I guess, but it is what it is. Ken, hey, how's it going? A lot of people here right now. Glad everyone's here. It's a good day. Java dev by trade. Yeah. So I mean, Haskell is a super fun language. Like even if you don't get to use it practically, it's really I think a fun language to make you think a little bit differently about the code you write. So give it a shot. And if you have any questions, like you can 100% ask me. We have a Discord, and like I'm 100% willing to answer any questions about Haskell if I can. Sometimes I can't answer them, but I will try my best. Um, hey Mitch, how's it going? I don't know if you don't go by the short version. I can't remember, but yeah, it is party in here. I didn't know there was a Twitch party yet. So happy final day of the year for everyone. If I mean, I guess in some places in the world it's already the new year, so hopefully they're probably partying or asleep because that probably makes more sense at this point. But anyway, um, Hitchhiker, where'd you go? Hitchhiker, the Hitchhiker. Thank you so much for the follow. I really appreciate that. Actually, we had another follower right before the stream started, about an hour before. Fairway Square, which is a cool name. What's going on, Hitchhiker? Are you aspiring Haskeller or just sort of interested in Haskell? Tangentially doing Haskell, Advent of Code. We've been talking about all kinds of weird stuff today. I like it. Absolutely. Yeah, I think somebody mentioned Learn You a Haskell. That's a great book to get started. Interested in functional programming? Yeah, if you're interested in Haskell specifically, oh, gonna start with Lisp. Very cool. Which variant? Do you have a specific one in mind? I've been meaning to pick up a Lisp, but I don't know which one to do, nor do I have time to learn one. So, well, it's not about time. I guess I could turn the channel into a Lisp channel if I wanted to, but I don't like it being Haskell. We're very distracted. I love it. This is going really well. Okay, so if we have a different style of person, we'll do another. We'll define a person prime, um, and we'll give it a new type constructor. Sorry, data constructor. Deriving show generic. Let's see. I don't. Oh, I guess I would have to change the the things next to everyone's name. Um, but I guess it doesn't really like all the emotes are now like uh they're snails. So there's that one, and then there's this one, and there is this one. They're kind of dumb emotes, but they exist. Working on Scheme, very cool. Um, Reading through the little schemer. Um, those I forget the authors of those books, but there's like a whole handful of those little typer, little whatever books. I haven't read any of them, but only because none of them are Haskell, I suppose. Um, Scott, how do I pronounce that last name? Yeah, unfortunately, you have to be a sub to use the emotes, but I did make it super cheap to use your channel points to unlock the emotes you want. So if you want one of those emotes, it's like ridiculously cheap to just unlock them. So don't hesitate to do that if you want to use one. Um, okay, so we have this person prime type, and I guess we can use this position thing to nice. We got one unlock. Very good. Like, I think it's strange that they hide the emotes behind money, but like I understand that you want to give incentive to users to or like viewers to subscribe, but I don't care at all if you subscribe, like not even a little bit. Um like I would rather you just hang out and we have fun conversations about stuff. It's way more fun for me. I'm going to do this anyway. So, oh right, we need to make a John Prime. Okay, so then we're gonna have a person prime and John 32. Indifferent ghost blowing up the. Wow, thank you so much, man. That's super awesome. Well, I guess I should call you. Uh, what a ghost? How would a ghost work? I don't know what to say, but anyway, thank you so much for the sub. We got let's see, 5 of them. Very nice. You did not have to do that at all, but I really do appreciate it. It's very cool. Um, Hitchhiker, Structure and Interpretation of Computer Programs is a great book too. That one's written in Scheme as well, right? Hitchhiker. It's some kind of Lisp, I think, but I don't remember. But yeah, 5 new subs. Very cool. Everyone should give Indifferent Ghost a round of applause, and let's put some purple snails in chat. Yeah, I like it. I wish that oh, I spelled that wrong. Spelled my own emo wrong. Very sad. There we go. 3 snails. 5 snails. Nice. Celebrate. Emotes, everyone. Okay. Let's see here. Okay. I'm super distracted, but thanks everyone. I'm having a nice day. It's very fun to talk about this kind of stuff. Talk about random stuff. Twitch streaming is all about being distracted. I'm pretty sure that is true. Okay. So, if we have what is this one? A carrot and a top hat? Oh, it's like supposed to be Frosty the Snowman. Script, yeah, I think so. I think Hitchhiker said yeah, scheme as well. I haven't read that book, but somebody recommended that to me a while ago. I don't remember who it was though. Maybe it was Lumi. Can't remember. Anyway, um, yeah, yeah, I got pretty good memory up here. Sometimes, not all the time. Okay, so this is sort of, yeah, we have like these fields in order, and we have a cat running through the things. I don't know if you can hear those back there, the blinds. Uh, do you here? Oh, hang on, I'll get the cat. Here's the kitty. This is Andre 3000. He's the coolest black cat ever. He's actually like a super smart cat. I think I've mentioned that on stream before. But he is a good cat. Hey, bud. Okay, back at it. Okay, so if we have like a non-record type, we can use this position thing, which is cool. Cool cat. Um, I was hoping sometimes he'll like get super close to the microphone and he'll sniff it, and then you can hear him sniffing. It's kind of funny. He's very he's very loud with his sniff, which is kind of funny to me. Like our other cat Layla doesn't do that, but he'll like really sniff things loud. It's kind of strange. Okay, so we simply pass the type level number of the field we want to access. Indexes start at 1. How dare you? And generic lens takes care of the rest. I suppose the position 0 is like um the record name. Sorry, the data constructor, I guess. So it makes sense to say it's 1. I don't really know. Maybe you use position at 0 for other things, like a prism or something. I don't know. Anyway, type lenses. Guess what else we can do? Yeah. He'll do this thing where he'll jump off of something and he'll snip, like he'll breathe outward through his nose really loud. So every time he jumps on the ground, he's like, I don't know why he does it, but it's very funny to me. Okay, so guess what else we can do? We can select fields by their type. Given the same data type we've been using, we're using person prime, but only because we're using one example. We can select fields using the typed lens. That's sweet. Okay, so we could do C John Prime view typed at string, for example. I should probably show what these are doing. So let me do that real quick. For anyone that's like um, unfamiliar with lenses. So the idea here is basically that we're looking into data structures. Okay, so these are relatively simple data structures, but we could have really complicated data structures that become kind of a pain in the butt to view specific. I don't know if it's true for every language, but it's specifically true in Haskell. It can be really a pain in the butt to like pull out deeply nested data structure components. So what this says is given the structure John prime, which is right here, it's like a person with a string and a number, view, it's the first position or something like that. I guess that's how you would say that. So that is like viewing this. And then we're also saying view the stringed type. So we can, if we had one string, I suppose we can do this. I'm curious if we put another string here, what will happen? So I don't know. It's going to be 123 example street. It'll be like his address or whatever. And okay, so we get an error if we try to use this because it doesn't know which string to put. I was curious if it would pick the first one and not the second one, something like that. So I don't know how we remove that ambiguity. Well, we would just use the position or have a record type and then use the field one, something like that. Okay, cool. Um, Daniel says closure, and I think Lumi would also agree that closure. Yeah, he just that's funny. You just wrote it as I was going to say that out loud. Um, Common Lisp is solid too. There's actually another streamer. I don't know if he said he was going to start streaming back up again. Commander underscore Thrashton does Common Lisp. Let me see, I think it's spelled like Thrashton, like that. Um, they work on Common Lisp. I don't know if it's SBCL or ABCL because I don't know what those mean, but I'm pretty sure that they're doing Common Lisp. Okay, so data int pair int. Whoops. Oh, this is just showing the type thing. We don't need to worry about that. Um, so typed will generate a compiler error if you have two string fields. Are these aren't called fields? What are these called? I guess they are called fields. They're still fields. I think that makes sense. It would be confusing if they weren't called fields, probably. Okay, so all together now. If you haven't gone mad with power, I'll introduce you to the arcane stylings of a new, deceptively mighty combinator simply called the. Okay. This combinator decides what to do based on the kind that you pass to it using type applications. That's cool. This I already read that, and will choose the appropriate behavior from one of the previously mentioned lenses. As usual, it's easiest to simply see it in action. It's I don't know if anyone else finds this really like weird, but the human mind will do very strange things to the sentence you're reading. Um, I don't know if anyone else has that problem, but I do. Okay, so we have that record defined already. Person, we'll use a regular person, and we'll check out the. So just for reference, this naming scheme BCD is a terrible naming scheme. Um, it's just because it's easy to like put in these examples as text. Um, aren't they just arguments to the data constructor? Yes, but I mean, aren't I guess you still have to call them. I mean, I guess you don't have to, but I would call them fields. Okay, I think that this is. What is this? I don't know what this is. Garden path sentence. I have a feeling that this is like that thing that I was talking about. Correct, a grammatically correct sentence that starts in such a way that a reader's most likely interpretation will be incorrect. The reader is lured into a parse, turns out to be a dead end, or yields a clearly unintended meaning. That's kind of interesting. I've never heard of this. E-Lisp, best Lisp. Kappa. Okay. I think that's probably a good kappa. The old man, the boat. Like, I don't even know. I don't even know what that's supposed to say. Is it a boat called the old man? Oh, right. It would be like if there was a comma there, the old, comma, man the boat. Like you just have to put your spacing in the right space or in the right spot, whatever, to make it make sense. Anyway, okay. So the name. Oh, that's weird. View the int. Ooh, I hate this. This feels like I don't hate it. What I mean by that is like I feel like this is it's voodoo magic or something. It's very tough to deal with. I feel like you would make mistakes doing this. Although I guess the compiler would catch you making those mistakes. But I can see how this would be tricky. It's kind of like reminds me of biplate. Like it's super powerful, but maybe you can do unintended things that you weren't expecting. That could be true. I think that so Haskell is one of these languages that it. Oh, somebody did a hydrate. Sorry, I just missed that. The five gifted subs kind of uh overshadowed the hydrate, so I apologize. Okay. Um, yeah, Haskell is one of these languages that is very, very different from all the languages that you're used to, right? Like I wrote Python, C++, and Fortran in like a historical order, going in older direction. Um, and switching to Haskell was like, what is this? Why is this so concise? And now when I look at every other language, I'm like, they all look wrong now because they're too much typing. It's like, why do I need to write this much to do these things when Haskell can do it very easy? Anyway, all right. So subtype lenses. Do you ever find yourself knee deep in Haskell code, missing the good old days when we all used to write object oriented code? No, I don't think so. Yeah, I agree with that, Hitchhiker. Like you think very, very differently about code. Although I will say that, like when I was first learning functional programming, I did it in Scala, and I personally found Scala like was getting in the way of me learning functional programming. And I don't think it's because that it supports multiple like programming styles. It's just that I didn't get it at the time, and it took Haskell to really beat it into my head how it kind of works. But yeah, I love it now, obviously. Okay, have I got a treat for you? Generic Lens has combinators which allow you to interact with subtyping relations on records. Like, I don't even remember what this means anymore. I haven't even thought about object oriented code in so long. Um, the basic idea, well, luckily Chris will tell us, the basic idea is that if the fields of one record, the supertype, are a subset of another record, the subtype, you can downcast the larger record into the smaller, or project the fields of the smaller record onto an instance of the larger. Okay. I'm in a nostalgic mood, so please come with me as I travel all the way back to my 200 level Java course. Wonderful. I saw a tweet about Scala switching theme. Instead of worse Haskell, they're switching to better Python. That's probably a good idea. I think that that's probably a good move. Like from a sales pitch standpoint, that makes more sense, I think. But they're gonna have to remove a lot of syntax to make Python people happy. Like I think that if I was really really looking for a language to replace my Python usage, I would probably pick Swift at this point. The problem with Swift is it's specific to a Mac pretty much. You can't even use their core libraries on Linux, which is like really unfortunate. Anyway, I won't get mad about Swift on stream again. I've done it a few times. That language looks really cool. Or yeah, that language looks really exciting to me. Yeah, I tried to use it on Linux multiple times, and it just is. It's pretty miserable actually. The experience is not very fun, but it is what it is. This is one of those things that's really weird about Ormalu is it tries to keep your formatting, and in this case, I really don't want you to keep my formatting. Ormalu, please don't do that. Um, but that's fine. Okay, and this is going to be a cluster, but let's just get all of this, and we'll just fix the formatting as we go. You'll see it like copy and paste. I don't know if this is specific to like the book or specific to the way events works. I'm not even sure. But we have to fix some of this, and then it will. Ormalu will help us out. Okay. Uh, so I think that we need. Oh, it doesn't. It's not smart enough to do this. I guess we need. What is it called? Duplicate record fields. Duplicate record fields. We should be okay. All right. Bring Smalltalk back. I've never used Smalltalk, but I hear people talking about it. Isn't there like a language that's meant to do that? Isn't it like Pharaoh? Is that what it's called? Yes. Well, I'm happy to have you. If you're watching Begin or Prime, that means that you're watching popular streamers. So that puts me in popular streamers boat. Yeah? I don't think so. Smalltalk is still alive, but there are a ton of design issues with its run times. Okay. But is Pharaoh is the language I'm thinking about, right? Pretty sure. Okay, so now we have yeah, Haskell is everywhere. Should be everywhere. We're gonna write lots of Haskell, probably for a long time. I don't know when I'll stop streaming. We'll have to see. I've been doing it pretty well, or I've been keeping up with it pretty well for quite a while. Really would love Haskell with a small talk style interface, interactive programming interface. That could be interesting. Although I never used it, so I mean I know that people talk about it being interesting, so we'll have to see. Formality. Isn't that unison? It. I don't know that unison would be considered small talk style. Is it? I don't know. Maybe it is. Formality. Never heard of that. Uh, Moonad. A great name. Formality? Maybe like this? I mean, example. Okay. Okay. I don't know. I mean, looks like something. Yeah, the syntax is a little weird to me. Like, that throws me off for sure. This looks almost like Python. I don't know. I don't want to look at this right now. Distracting. Yeah. Nice. I like the interpretation, Skybro. Drink time. Thanks, Moobot. You're the best. All right. I should probably keep working. I'm distracted. You guys are doing a very good job at distracting me today. I appreciate it. So we need some apartment or something. This distract. Yeah, we're really stretching it out, I guess, but not with content. If somebody actually makes it all the way through the YouTube series and they get to this one, they're gonna be like, "What was he doing? He wasn't even doing the book." Can't even type anymore. Okay, so we've gained. Whoops, dwelling. Okay, so view a projection of fields from the apartment as a dwelling. Okay, so we have an apartment which shares num bedrooms and a dress. Okay, this kind of makes sense, I think. So this is what is this called? You're probably the first person to actually read every single chapter in sequence. Prove it, Skybro. Prove it. You can't, can you? You probably can. I imagine you have it on GitHub. But I can prove it. I got videos. Script. New Year's Eve food. Nice. Have a nice stream. Thanks. Take it easy. It was nice to see you again. Hopefully we'll see you soon. It says first next to my name. Nice. That's pretty clever. Winning. He wins this argument this time. I can't debate that. Okay, so what is this called? This isn't a like a prism. What would this be? Because you're like, it's I don't know. I don't know what this is. I guess it's just a normal view or a normal lens. I don't know what the name is though. Maybe you mentioned it down here and I missed it, or maybe it's below that. Okay. Where did it go? App super dwelling. So view a projection of fields from the apartment as a dwelling. Yeah, it's just a lens, I guess. Yeah, just a lens. Okay. Uh, the provided upcast function does the same thing. Upcast. Upcast. Okay. Oh, this is just a function. I was like, wait, what? What is this doing? Can also project the fields from some supertype down into a subtype, replacing only the shared values. Okay, so this is what subtyping means. Is like some fields are duplicated between different structures, and then you just kind of deal with it. Yes. Dwelling. So what do we do about fields that are missing? That's the part I'm going to be interested in. Um, okay, so we can apt. So all right. So what is this saying? So take the apartment and view it as a dwelling and set it to dwelling. So is this going to end up behaving like a prism where we end up with an apartment with a new sort of dwelling information? I have a feeling that that's what's going to happen. 2020 Willow Street, dumb bedrooms 3. Yeah, cool. So this is using super as a prism, I'm pretty sure. Okay. Smash. Smash. Is this at all related to that library Smash from um gosh, can't remember her name. Go look it up. Haskell Smash Library. Emily, thank you. Emily Pillmore. There it is. Okay, no relation. Fair enough. I was just curious if they were the same thing because like that's a pretty specific name to use. But I guess you're kind of just like smashing the two things together, something like that. I remember that Vlad was working on a pure script version of that library. I don't know. I assume that that's finished. Okay, so note that this only provides data subtyping and doesn't provide anything for handling behavioral subtyping. I don't know what that means, so it doesn't matter. Um, yeah, there you go. For reference, I Chris might be able to answer this, but there's probably actually a better link to use to get a little bit more cash off. I think it goes until the first. You can check his Twitter for a little bit more money off if you're interested in the book. Okay. Nonetheless, it's quite handy when writing functions deal with a subset of data shared by many entities. Okay, so generic traversals. So types traversals. We saw an action on saw in the section on typed lenses that typed will fail to compile if there's more than a single field of a given type in your structure. This is of course because lenses can only focus a single element. Traversals, on the other hand, have no such issue, so generic lens provides a traversal which focuses all the values of a given type. Okay, cool. So this is what I was curious about earlier. Nice. There you go. Thanks, Chris. I should have just looked it up for you. You didn't have to. You didn't have to do that. Well, I suppose it generates you revenue, so it's potentially so it's worth doing. And I would 100% recommend this book just for reference. Like if anyone's actually curious about that, I really like this book. I'm definitely excited to figure out where I can use lenses. I don't want to just force them into my next project though, um, unless they make sense. We'll see how that goes. We're on I. So int pair 1 to list of types int. Okay, so this is going to generate a list of 1 and 2, I guess. Yep, that makes sense. We could use all of our normal operators for traversals, so that makes perfect sense. Um, oh, this is kind of interesting. Like if we looked for strings in a type, it just gives us an empty list. It's sort of nice that this doesn't fail, I guess, but this might do weird things if you're not careful. I almost wonder if this would be better to fail. I don't know. I guess this is failure. Uh, I guess you wouldn't want that to error, so I guess this is fine. Uh, just being silly. Okay, so parameter traversals. I think this is my favorite optic from generic lens, not because it's the most useful, but rather because it's the most unique and interesting. The param traversal allows us to focus values in a structure based on their position within a type parameters list. Param traversal allows us to focus values in a structure based on their position within a type parameters list. Check this out. I really like this book too. I like it because I can use it like a reference where I can jump around to find out the right optic for my task. Yeah. Uh, yeah. Okay, so param data list tuple tube tuple list B driving show generic. Cool. So I think that after the stream, or well, sometime tonight, I'm gonna try and finish all the videos in the series and get them on YouTube tomorrow, so that the entire series will be on YouTube tomorrow. If for some reason somebody wanted to watch the whole thing, even in 2x, I feel like it would be way too much content. Um, okay, so now we have this. So we're gonna have an example called tup. It would be a lot. I'm not sure why anyone would do that to themselves, but like, you can. Do I really need to define that? Probably not in this particular case because we're not using overloaded strings, but that's actually true. That's a very legit point. Uh, I really like that joke. Yeah. It's so sad. Ugh. Don't make me think about that again. It's so miserable. Like, how did you ruin that so bad? I don't understand. I'm sad now. Not a good start. Not a good start to my new year. Okay. So, anyway, select all values of the parameter furthest to the right. What? Why? Why is this furthest to the right? Feels backwards. Okay. Um, I'll just write that this is. Let's just copy and paste this. Who knows? But I legit want to read them because I want to know what's supposed to happen. It's very frustrating that we don't know what actually happened. This is kind of weird to me. This is very counterintuitive, I feel like. Okay, so type parameters kind of grow from right to left when you think about how type classes interact with them. Oh, sure. Okay. That's a good way to put it. So it's like because we're talking about functors and traversals, we're going from right to left. I can deal with that. That's fine. Um, or like I can use that in my brain to hopefully remember it. Okay, and because it's a traversal, obviously we can do this, which to me. Um, as you can see, param introspects the type and finds all occurrence of the specified type parameter from within the type. One thing to notice is the type parameters are zero index from the right to the left. This is just a quirk of how they're represented in the underlying generic types. So just keep it in mind when using param. Yeah, yeah, and I guess this comparison to functor is pretty helpful. Um, or maybe you're just using that as an example, and that's not really why it's that way. But I'm fine with it either way. We can see from the above examples that it will find all values of the specified type parameter, even when they're nested from within other types, and distinguish between type parameters even when they have the same type. Makes sense. Okay. Constructor prisms. Just as we can generically construct lenses for working with record types, we can generically construct prisms for working with some types. The underscore CTOR constructor prism allows us to construct a prism on the fly by passing it the name of the constructor we want to match on. Okay, so let's get this type in here and start working. Videos, DVDs, VHSs, Laserdisc. I don't think I've even seen a Laserdisc. Is that sad? I think it was just like the tiniest bit too old for me. We want I don't know if this is gonna cause errors. Hopefully it doesn't. Um, okay, so we can do uh, L. If you have not seen The Princess Bride, like, what's wrong with you, first of all? Second of all, go watch The Princess Bride, please, because it's amazing. Okay, so this is like identity for a lens, or for a prism, I guess, in this particular case. And if we used like VHS or Laserdisc, we would get nothing, I suppose. So let's put that down here. HS. Okay, so L. Yep, and then M be nothing. Perfect. That error wasn't actually an error. Okay. So this is, oh, this is cool. And so we're constructing a video, a Laserdisc video called King Kong. Usually, so this particular operator is called review. I usually say like materialize or something. I think that term was used previous in the book, and it was kind of useful, I feel like. Okay, so as expected, we get a nice error message if we misspell a constructor name. So yeah, we don't have high definition DVDs or anything, so we get an error. Cool. Uh, Typed prisms, just as we can write typed lenses for product types, we can write typed prisms for some types. We simply tell it the type of the contents we want to extract, and it will generate a prism for the appropriate constructor. Okay, so data, I don't want to write this, I just want to copy this. Oh, so num ID typed int. Okay, so this is going to grab the num ID int. So we'll just get just num ID 3 in this case. Yep. Oh, wait. I was expecting us to get the constructor as well, but I guess we don't. We would have to use the constructor at num ID to get that. So we're just getting the 3 here. And if we had a string ID and then a string, obviously that would give us nothing. Okay, this makes sense. If we try to use bool, there's no bool in here, so it complains. Or if we ask for a type that's ambiguous. Oh, okay, so if we use type string, it doesn't know whether it's a left or a right in this case. And I guess if we used p, well, I'm gonna put this one in here. Actually, let's just say question mark. Yep, we've got a new laser disc back. Okay, good. I don't know what happened. Like, thank you for putting something in the chat because it seems like the internet just completely dumped out for some reason. So we'll see if that happens again. I was going through a VPN, so maybe the VPN itself got overloaded, and hopefully now we're on a different server that isn't a piece of crap. But we'll see. Or well, I mean, I guess it doesn't mean it's a piece of crap. Somebody could have just overloaded it. So anyway, it looks like we're back. So here we go. So I don't think you missed anything, probably, but maybe. So what I was looking at was just this section here, and just saying like, if you have an either string, how would it pick out which piece to use? You have to be specific. So if we had left ambiguity, that's a string, we could type the string. So you can't have an either a type. It has to be either a b, which makes sense, I think. So yeah. So sorry about that little outage there. I don't know. I don't think there's anything I could really do about it. Uh, I'll just keep an eye on my bit rate here, and we'll see if it blows up again. Okay. Here we go. So exercises, our favorite part. This is what we're here for. Exercises. So throughout these questions, note that most of the combinators we've explored have associated type classes. Look them up in Hackage docs for generic ones. They sometimes have a simpler version of the combinator suffixed with a prime. For example, it's often easier to write type signatures when using field prime rather than field, since field prime is a simple optic. Okay. Use the has field prime class and its field prime combinator to write a function which accepts any record with an email field and validates that it contains the at symbol. And that it contains. Oh, okay, I see. Like it has an at in the email itself. Okay. So let's put this here, and we'll write undefined. And also that this can't work. Okay, so this is a simple optic, so it's going to be email, and then S S S A. Okay. So the constraint has field matches instance context. Oh, this is just a warning. But I think that this is actually supposed to be like that. Not 100% sure yet, but I think so. So we'll see here in a second. Okay. So this S is some generic structure that has an email field. So I guess you just can do we can do row polymorphism in Haskell now. Where are you getting that? Can we? Oh, I guess technically, yeah, this is kind of like row polymorphism ish. We can't extend we can't extend records with new fields. That's a thing you can do, right? In uh in PureScript, but we can have generic uh as long as we have a field email, then we should be okay in this case. Yeah. So it's half of row polymorphism, I guess. So what is this? So this cat is pretty loud. I don't know if you can hear the cat. Um okay, so this is gonna complain because we can't match A with field, which is fine. Um but this A needs to be probably a string. So I think that this should actually be string. And then we need to make sure that this contains. So there's gotta be that I'm gonna forget. Kitty, you're fine. Come here. Come here, Layla. We're gonna have to say hi to the cat, I think. Layla, come here. Okay, she's not coming in here. Um, but we'll see if she does. Usually, if I call her, she'll come in, but she's not doing that. So we want to say, oh, here she is. Hello, baby. Here's your key. Hello, Layla. Hi. Okay. Yeah. Little eyes. You don't know you're on TV right now, do you? You're on someone's television. How's that feel? That good? Okay. Oh, what is it? Oh, these the little additions that they add to people's emotes are so funny. Like they look so strange. Okay, so we need a lens that basically just says like do this function to convert this thing to a bool. Um, which is what is this one called? I literally did exactly this same question mark last time. Yeah, it's basically a cat stream. No, to be fair, the cats are not on stream as much as they have been today. So uh, usually they're usually they're pretty chill, hanging out with my girlfriend, like in the rest of the apartment. Bye, Swarm. Nice to see you again. Um, what is this stupid thing? Oh, over. Well, no, but that gives us the whole structure, which is not what we want. We don't want to have the structure with a boolean. That wouldn't make any sense. I always forget about two. Two is a weird one to me. So we're gonna have lm of. Actually, I don't want to do that here. I want to look at it over here. Does the element occur anywhere within a given fold of the structure? We certainly want to just use that, I guess, because we're just gonna traverse over the string, and then we should have a bool. Um, we just look for the character, or two. Two is one that I think throws me off. Well, that's not the right one. Build an index preserving getter from an arbitrary Haskell function. So this is like, uh, yeah, I think that makes sense. No, that's not what I want to do. Oh, right. Let me put this back because I need to be able to see the bit rate in case it drops to crap again. Um, so yeah, we definitely want lm of. think. And then this needs to be reversed, probably. LM of is an action. Man, I'm losing already the terminology. Oh, right. I know what you're saying. Um, I think we can do it just like this. And we also can remove this, I think. Oh, so the lens comes first. I just need to look this up. Okay, so we're gonna have the lens, the A, the S. Okay, yeah, there it goes. It was just taking a second to think. I just had it backwards. Um, so let's see. Validate email field. It's going to take the string, or sorry, it needs to take a record. So do we have email in here somewhere? I don't think we do. No. So we need to just define a record called an email. Milad, hey, how's it going? Yes, there is a way to access previous sessions via my YouTube. So there's the YouTube link. There should be a optics. Well, actually, let's go look because I'm not even sure now. But I'm pretty sure that if you look here, there is optics by example, and you could just like play them all if you wanted to. So I have like you'll see private videos here because I haven't released them apparently. I need to go through and edit a bunch of these videos to get them done. So like this is actually a pretty old video at this point. Well, it's not that old, I guess, but this was before I moved. You can like there's my old room, for example. But I guess this is the first one that I did, and probably the first chapter, maybe the first two. Yeah, look at me, so young, so naive. Not even half a year ago. Anyway, yeah. So if you want to check that out, I promise that I will release these videos very soon. I just need to go through and edit them all. It'll take me a few hours to do that, but I'm hoping to do it for the new year. So we'll just make like an email type that has an email field that is a string, I guess, and deriving, show, and generic. And sure, this can be a new type, and I guess that won't be an issue. We'll find out. I'm actually curious. Okay, so then we should be able to reload and then do validate email field, email uh broken broken at gmail.com. Please don't please don't email that person. Um False. Yeah, that's what I thought. If we do that, then we would do this. But maybe that's the issue is that we needed traversed, but why? So I guess it was looking for so it was searching the entire string for like exactly um like ampersand, but it was finding just B and then going, no, they're not the same, something like that. So we need to actually traverse over the whole thing, which I think makes sense because we need to look at every character. And if we don't look at every character, then it's no good. So nice. Cool. So there we go. Yeah, exactly. And they weren't because there's only one string that it was looking at and it was the entire broken. Yeah. Yep. Cool. That makes sense. And once I saw the error, I think it made sense. But I wouldn't have written that. I did try to write traversed earlier, but I got stuck on the fact that elem of is an action, which I don't know. These always throw me off for some reason. Okay, anyway, that was cool. So write a function which accepts. Oh, I need to put something here to just say, like this is the first exercise. I don't really have to, but okay. So write a function which accepts a structure and a value, then sets the value to the first positional slot of the structure. You'll need to somehow require that the value matches the appropriate type of the slot, the first slot of the structure. Try it using the simple optic position prime or trying a more polymorphic version using position. Okay. Uh, we'll just grab this. So we're gonna use this has. Wait, no. This is a position, so it's not as field anymore. It's gonna be like I don't know what goes here yet. Something. Um, so we want to look at the type of position prime, which is theta generics lens or something. No. Um, product. And then, whoa. Okay. This is probably not what I wanted to look at. Maybe it is. I don't see any has stuff in here. Maybe there's something like that. Where's has field? Okay, so we want to go look for position prime. Um, lens, sorry, Google position prime from here. Okay, so has position I. Okay. Oops. Button. So has position 1 because we start at 1 and SA, I guess. So the question is, how do we do this? So structure at position prime 1 set A at 1. Okay. So the constraint has position matches context. This makes type inference for inner bindings fragile. I think that's okay. So I think that this is right. So set first simple. So we need to have something with a 1 and a 2. And I think we can just use person for that. So oh, I should put examples here. Sorry. So let's do that. Q. here somewhere. This one. We'll change this to like okay. And R is broken. Not okay. Like that. And then S can be set first simple. We'll start with the structure, which is going to be person, Cairo. I think I'm 32. And we'll set it to 33. This won't work because it needs to be a string. We'll fix my name, I guess. Something like this. I guess. Really, though. Sort of. Um, so then S. Yeah, that seems to work. Good. I don't really understand this warning offhand. I think it's just because has position is here, but I suppose it almost doesn't matter. We could like put n here, and oh no, will not behave the same. That's interesting. Okay, so that first complex has, yeah, I don't know what it's about, to be honest. It might be because of some of the extensions I have enabled at the moment, and they're actually causing that warning to pop up. Maybe if we use like I don't know. It just says like monolocal binds, so I'm unsure what that's about. Yeah, that's what I was thinking too. Okay, so this is gonna be one, and then it's STAB. Um, but I would have guessed that the implementation is exactly the same. You just have to use position at one set B. Yeah, I imagine if I remove some of these extensions, that this might go away. So I'm not concerned about that. We could turn it off as well, right? Um, we'll just turn this off, which I actually don't remember how to do. Haskell pragma disable warning option. So we need this. And then this. But how can I turn it? How do I turn it off? W dash X? Is that how you turn a warning off? Warning. Kind of cool. But that's not what we want. Options GHC. Okay, flags. Look here. No dash. That's right. Um, so no dash. And goodbye. We did it. Look at us. I don't do that very often. Like I don't have to. We're just turning it off for sake of remove hello squiggly line, I guess. All right, so that's cool. So then, and do we put an example? I'm not sure that we have to, but we can. But wait, how does this work? So in this particular case, we can't actually set the other. We can't change the type because it's not polymorphic. So we need something with like an A, so we can do that. I think we have something like that somewhere. Um, Not int pair. We could use list tuple. Okay, so we're gonna say list tuple 0 because it doesn't really matter what's there, and then 0 is 0. And then we're going to set this to, doesn't really matter, I guess, hello. And I think that this should work. T, yeah, so that makes sense. All right, so 3. Now, actually, one thing now I want to check as well is, can we write the following? I don't actually know that we need this. N. Oh, but this has to be in, probably. I forget how to do this. It's like you need to promote the integer to the type level. But I don't remember how to do it. Hang on. See if I can find it. Pretty sure there's a way to do this. But I just don't remember what it is. I have no idea what this can go away. So if anyone remembers, oh, it should. Okay. And then I think this is 4. Um, yes. Wait. Right. Yes, yes. And get rid of um overlapping instances for has position. I think that this needs to just be, wait, no, but how would we do that? Do I need to make a new type? Yeah. So we need to like create a new type that contains this as a nat level variable or something. I don't know. Let's see if I put n here, what happens. Oh, it does say allow ambiguous. Okay, well that seems to work. Um, but let's see if it actually works in practice. Um, so we're gonna do basically, yeah. I mean, GHC tells you, right? It's pretty useful. I didn't even try to like read the error that carefully. I should have, obviously. So set complex will take a natural number. We'll use 2 this time just to do something different. And then we'll take a structure, which will be this list tuple that we used before, wherever I put it. Oh, it's up here. We'll just grab this list tuple, and then we'll try to set the second one to hello world or something. Oh, yes. So SX type applications. We might have to turn up. Oh, actually, let's just do this up here to U so that we don't have to worry about all this type machinery going on. Okay, so reload and then U. Yeah, cool. So we can do that, which is pretty sweet. Oh, you got lucky. That's true. You didn't see the error. All right, that's pretty sweet, actually. So 3, we're going to do get member using use typed and the has type class to implement a function which uses type inference on its return value to get the appropriate type from its input. Use typed and implement a function which uses type inference on its return value to get the appropriate type from its input. Don't understand this question. So we're trying to get we're just trying to get a field but using its type, I guess, is what this is saying. So do we really want this? Um, is this what you mean? How would I say this? I'm not sure how to say your name. Is that an I or an L? I'm just gonna call you Rollier because that's the or Rollero or roll. Anyway, it's cool that you're learning physics via Haskell. Or are you saying I'm learning physics via Haskell? Not sure, but yes. I do not understand this error at all. But I'm having a hard time understanding the question, I think. Oh, this is supposed to be like this probably. But maybe it's the other way. Um, type, yes, a s. But we don't know the functor. Oh, this is backwards as well, maybe. I just looked at it. Yeah. So has type goes the other way. The structure comes second. The A comes first. So I guess this is okay. Seems to work. What's an example of where I need to do this? Um, deep. doesn't know anything about snails. And Skybro asked 30 minutes ago, which I just missed, or well, I missed a while ago, obviously. But it wasn't anything about snails, which is unfortunate. But we did get some stuff about snails yesterday. You guys want to hear? Uh, So Commander Thrashton gave us the smallest snails are smaller than the eye of the needle, of a needle, I suppose. So you can have some pretty tiny snails, which is sweet. Also, did you know that snails have lungs? Well, some of them, not all of them, I guess. And salt will kill snails, so don't kill snails, please. Right. If you're like confused at why uh, talking about snails, I just have like I like snails, and my um, stream has snail emotes. So deep. I feel like I haven't seen you in a while, but hello, how are you again? And what are optics? So optics are a cool tool to basically reach into complicated structures and make interesting changes. So we'll just look at an example. Don't worry so much about the type; it's a little bit more complicated, obviously. But what this is saying is given some structure S, so for example, this structure, at the position N, so the positions are like this is position 1, this is position 2 in this case, set the value B. So, right, B is just an input. So S is an input, B is an input, and what we're going to do is set the position uh, to B if it exists. If it doesn't exist, this will do nothing, basically. Um, I think, or it may complain. Not sure. We could try it. So this is what this will end up looking like in practice because that's just how you have to run this set complex thing. So this is kind of like a weird example. We've done a whole ton of more simple examples, but we're learning about generic lens today, which is actually relatively complicated. Let me see if I can find another example. All right, so here's another relatively weird example. What this is saying is for the field email, and this will take up any type that has a field email. So you can have, like we obviously have the most simple email, but you can embed email in a relatively complicated record. And this will say for an email that's a string, or a field email that's a string, go through it and see if you find a ampersand. Or sorry, that's an at, not an ampersand. Um, if you do, this will return true. If you don't, it will return false. So Q will be true. Q will be true, and R will be false in this case. So there's another example of an optic. There's also these things called prisms, which are pretty cool, and they allow you to like match on um, data constructors. So this is like some data constructory stuff. We can like construct them using these. They're a little strange for generic lens. I would probably step back and learn about basic lenses before jumping into this, but I'm pretty sure that this is right. So let me see if this works. So we're trying to find uh, a member from its type. So we could use this list tuple thing. So get member. We'll use this exact example, I guess. But get member. What we're trying to get the structure is let's put it here as a type def. So type structure list tuple integer list integer. So if we write structure here and then at list, I think you write it like this integer. Let's try the simpler version first. See if it works. Yeah, we don't care about this. How is list tuple defined? It's A, B. Oh. So let's do string so that we don't have this issue because it's going to be confusing, I think. So we'll just do this. And then I guess if we do V, we will get 0, yes. And if we change this to string, wait, what? Couldn't match type list of car. Oh, right. Wait, no, that doesn't make sense. I don't understand. So does this need to be? Yeah. Okay. So right, I'm confusing the types here. So the S, sorry, the A that we're trying to look at is, sorry, the focus is the term, is list of hello. So here's the focus, and this is the structure in this case. But that's different than the types, so I just need to be careful about that. So let's see if this works. Yep, perfect. And then I guess we couldn't get like just the string hello without doing a more complicated setup. Okay, so anyway, that's get member. These are pretty hard actually. They're just a little mind bending, I suppose. Okay, so 4. Use super with the subtype class to write a function which validates the email address of any record which has one. You may need to find, to define, I think, to define a data type to accomplish this. Use super with the subtype class. Okay, so somewhere here we're gonna write like subtype, and we can just do I subtype. Um, soup sub. So, soup sub, and use super with the subtype class to write a function which validates the email address of any record which has one. Don't understand this. I think these are just kind of tricky questions to write. Not that surprised. Let's go look at super again. So this subtype is like string. So I think it's just S. The super type is S and the subtype is string, maybe? And then we can probably use this again. Uh, super. Need to look. Super. So we're viewing the super of the apartment through the dwelling. So we want to super string I don't really understand. Um, So super subtype is string, I guess. But how do I? So subtype is a dwelling. So if we have an email, the subtype would be string, I guess. Supertype is some structure S. Oh, I was hoping that would work, but incoherent instances sounds pretty scary. So at string at S, maybe we can just put an underscore here because it's smart enough to figure that out. And then we should use for all S. I don't understand. The super is upcasted subtype to supertype. Why is this? Oh, because it's lens. I think I'm. Oh, this seems to be backwards. But what does this do? Does this do what I think it does? I have no idea. Validate email. Email. Hello. Do I have multiple validate emails? I have validate email field. What is this complaining about? That's clearly incorrect. Um, I feel like this is actually backwards, but maybe if I do that's not a thing. And then this gives me some really weird error. Super type supposed to be something which has the field email. I don't understand this one. I'm confused. Go look at the answer. Very confused. Hmm. Yeah, this is not what I was expecting at all. Um, so the subtype, I don't understand. So the subtype, are we supposed to give this thing an email? What does this do? I'm now legitimately confused. I guess it doesn't. So we're not giving it a subtype. We're giving it a super type, aren't we? Um, I don't understand. The super type is an email, but why are we writing sub here? Isn't the subtype like a string? I don't I don't understand this one. I think I'm misunderstanding the question, but that's fine. Um, Note and to look this one up. Doesn't really make sense to me, to be honest. We also don't need this. Okay, so 5. Maybe this one will make more sense. Not sure. Okay, so use any type classes you need to write a generic implementation of fmap, which works for any valid functor type, has a generic instance and the proper kind. Maybe be okay. Um, so what do we have here? We need something. So we're gonna have a structure S, which needs to have a particular shape. So it's gonna have a field A to, or wait, F of A. So how do we make that work? So it's gonna be typed. Okay, so let's see if we can figure this out. I think we need typed. So F A, and then has type is backwards. So the focus of this type is going to be A. So F A S T Well, let's do this. Okay. So also F needs to be a functor. So functor F. I guess this will be enough. Not complaining yet. So we're gonna say what? S typed F over. Oh wait, that's not right. So no, F is an A to B. That's not really right. We need some other, not for all. Well, we can't use scope type variables. Let's put G here. No, that didn't work. Oh, wait. So this implies functor F, but the focus itself needs functor. Then we should do that. Apply G to it. I don't know. This seems right too, but I don't. Sure. Let's look at the error. Okay, could it match expected type T with actual type S2T? Yep. Fortunately, this doesn't give me enough information. I don't think. Oh, there's more up here. Suppose that's helpful. Okay, so could it match A with S identity T? I tried putting S here as the structure, but that doesn't work. So what's the type of typed again? So it's supposed to be has type A, which is FA, and then the structure, which is supposed to be S. And F is just some functor, so we don't need to specify that. Maybe we do, but I don't think so. A as type focus S. I'm not sure. Nope, I don't understand. Why does this work? So has param 0 just means it has a constructor and some type, like an A, like an FA. But we don't have to imply that F is a functor? Hmm. Any think that any new type can be trivially turned into a functor. So maybe this makes sense. I would have guessed that we would have needed to do more like checking, but apparently we do not. So okay. Um so tried this, but it doesn't work. Unsure how to doesn't compile. Unsure you can do something like this. Sure. I don't understand these at all. I feel like, but that's okay because I can't think of a use case for this yet. So, last one. See if we can figure. Not sure we're gonna be able to. Hey Christian, what's going on? Maybe you understand this. I don't know. So we'll just call this. I don't understand this. I'm very confused. W. Very, very confused. Okay. I need to shut my door. Just 1 second. It's hard for me to focus when I can hear noises in the. Okay. So what's the idea here? So if we just need some kind of typed at int or something, don't we? Um, no, we need something from some type because those are the prisms, so that's not gonna work. We need like underscore typed int. That's what we need. And I think this will work. So this is like I don't know what kind of prism this is. int typed prism typed int okay. So there's int typed prism. So wx int typed prism construct, or sorry, I guess we're doing this instead. Okay, so that doesn't work. Unfortunate. I was thinking that we could just use typed there, but I guess not. Because both of those have integer types. What? Could it match type tagged? Tagged. So we just, do we need to like say int typed prism requires a tagged s? I don't really, not really sure. Import data generics sum. Okay. Silly cat. Um, I don't know. I don't really understand this one either. These are really weird to me. I'm glad somebody smarter than me figured this out. Sit down. Think about it. I'm actually. Oh wait, this is actually an hour plus however long we streamed before. That's right. The stream went down randomly. Um. So what other prisms do we know about? We know about typed, and like that worked. Typed at string. That one worked. Typed at int. So like if I just put typed at int here, does it work? Because I would guess that it does. W X. So this is just a matter of getting the types right. Silly kitty. Typed at int. Yes. That X type applications. The cat is totally fine, by the way. Just wants attention. Don't be worried, a little kitty. And both my girlfriend and I are working right now. I mean, I guess I'm not working, but yeah, poor kitty. Okay, so we're just placing int in here. And then, yeah, I think I'm almost done. So I don't actually know how long we've been streaming. So I'm going to go hang out with the cat probably. But so I think that this was just complaining because of the inferred type for typed int. It was probably being too specific, and that was being the issue. And when we sort of made it more generic, it was okay. So we just like put in the type here, and it was doing something like inferring the type based on the usage here. I'm not exactly sure how that works, but it seemed to be using the type inferred here, which maybe is even more specific. Let's look. So like if we do this, what does it do? Actually, let's first comment this out. And we'll also comment this out. I have to sneeze 1 second. So let's look at the type here. Yeah, so this is something with tagged, which I don't really know what that means. And then this is also getting tagged, which is clearly too specific. So we need to make sure we have the most generic type for int typed prism, and then you can see that that retains that more generic type. And I would guess that this will look exactly the same. I wonder if we comment this out and comment this out, if it still compiles. And it does, because it's able to infer the, I don't know, whatever this is. This looks like the p int f etc stuff. So that looks like the more generic type as well. Chrono,